Today, every business is a digital business. Most of us are migrating workloads to the cloud, adopting DevOps tools, rolling out RPA software, and supporting a remote workforce. While opportunity is great, so is the risk of advanced cyber attacks. Many high-profile breaches start with a compromise of privileged credentials. CyberArk is the #1 leader in privileged access management. Talk to CyberArk today to secure privileged access for humans and machines across hybrid and cloud environments and on endpoints. Learn more at securityweekly.com/CyberArk and stay one step ahead of the attackers. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Enterprise Security Weekly. Learn how hidden vulnerabilities lead to application compromise in our next webcast with Sneak. Our second one will be with Google Cloud, teaching you how to prevent account takeover attacks. You can register for all of our upcoming webcasts at securityweekly.com/webcasts. If you go to /on demand, you can register for and watch our previously recorded webcasts. I'd like to welcome our special guests for this segment. Aaron Rinehart currently serves as the CTO and founder of Verica and has been expanding the possibilities of chaos engineering and its application to other safety-critical portions of IT. Aaron, welcome.
Thanks for having me.
Casey Rosenthal is the CEO and co-founder of Verica. He is with us today. He's formerly the engineering manager of the chaos engineering team at Netflix. He has experience with distributed systems, artificial intelligence, and translating novel algorithms and academia into working models. Casey, welcome.
Hey, thanks. It's great to be here.
You both bring a wealth of rich knowledge and experience with this thing that we call chaos engineering, and I think it's a great place to start. Either one of you maybe take turns kind of talking about your background and explaining what exactly is this concept of chaos engineering.
Sure. Yeah. So take you back about 5 years ago, I was hired to Netflix to manage some teams in an availability context. And at the time, Chaos Monkey had been a program that Netflix had built and open sourced and blogged about that basically turned instances off in AWS for the purpose of making sure that Netflix could survive when that happened in an unanticipated way. And so when I got there, they said, okay, we've got this Chaos Monkey thing. It helped us in our digital transformation, moving from the data center to the cloud. Mm-hmm. So maybe you can do more of that chaos engineering stuff. So I had a charter for a team, and I basically went around Netflix and then around the industry and asked, okay, so what's chaos engineering? And the answer that I usually heard back is, oh, that's when we break stuff in production, mm-hmm. which sounds cool. Unfortunately, we could do that all day long and nobody would thank us for it. So instead, we sat down and explicitly defined a new discipline in software engineering that focuses on a proactive methodology to improve availability. So if you look at the other common disciplines out there in availability, incident response management, alerting, remediation, disaster recovery, those kinds of things, they all focus on time to detect and time to remediate, which is important, but it's all reactive. And so we wanted to define a proactive way to improve availability. And so we did, and that kind of kicked off, we wrote the definition as a manifesto of sorts at principlesofchaos.org, and that kind of kicked off this discipline of chaos engineering. Now, about a year after we had started that, I was lucky enough to meet Aaron here, and he opened my eyes to the application of that philosophy to security. Aaron, do you want to jump in here?
Yeah, sure. So, at the time, I had started exploring the possibilities of applying chaos engineering to cybersecurity. I had just sort of come off the DevOps transformation for United Health Group. I was the of serving as the chief security architect for the company. My job was to sort of, drive the engineering portfolio forward for security for the company. And, we hired our first SRE, which is site reliability engineer, and he started talking. He was from bestbuy.com, and he started talking about these concepts of proactively sort of injecting failures and bringing down instances, and and the concept started making sense to me from a security perspective. Because my background, before I got into cybersecurity, I was an engineer. I was a network engineer, a system engineer. Then I was a software engineer most of my career before I got into security at NASA. And so I've never seen the system and its security being like two different things. It's either the system is secure or it's not, right? So it was very easy for me to. So the use cases I began with applying chaos engineering to cybersecurity was really around control validation, right? Is as a chief security architect, I provide recommendations, but I'm never quite sure if those recommendations actually get implemented or implemented correctly, right? So I needed a way to skip all the people between me and the system and ask the computer the question. And I did that by injecting faults and failures through an open source tool we created.
Yeah, that's interesting. It seems like you borrowed a little bit from agile development process, right? Did I capture that correctly?
Maybe. Go ahead.
Yeah, so a little bit. The connection there really is that agile and XP before it really kind of discovered that you can improve the safety properties of your systems, availability and security, by enabling engineers to optimize for reversibility. So in a complex system, you're going to make mistakes, but what differentiates a fragile system from a robust one is your ability to identify the mistake and roll forward or roll back, change the decisions that led up to the conditions that you don't like quickly. Right. So we see some of this in the evolution from CI to CD to CV, continuous verification. But that's definitely one of the things that XP kind of introduced into software engineering from a process perspective. And then Agile kind of brought that forward. And now we're seeing you can actually make architectural decisions about your technology that improve your reversibility.
And when you say this happens in production, I just want to address that point, right? Because I think there's people in the audience going, oh my God, what do you mean you're bringing things down in production? Like, that's horrifying to many of us, especially those of us that are used to racking systems in a data center, right?
Sure, yeah. And it's not, so, it's called chaos engineering. The point of it is not to break stuff in production. The point is to fix stuff in production. So it's not that you're engineering chaos, it's that you're assuming in a complex system, you already have chaos. And so how do you engineer your way around that? So the high bar, the gold standard for chaos engineering is that you're studying your system in production. But that doesn't mean you start there. There's a lot of value to be gained from doing game day exercises and doing these kinds of experiments in a staging environment. You learn a lot that way. In fact, you learn a lot even just getting people together and thinking about what a chaos engineering experiment might look like, and having people, explore the different boundaries of your system's safety posture. So yeah, in production is a gold standard, an end goal. There's definitely warranted some skepticism when you're getting started, but typically what we've seen is the digital native companies first, like Netflix and Google and FANG adopted these practices up through production. Then we saw kind of the big fintech companies follow that lead, and now we're seeing this as more of a now healthcare companies, and now this is more of an industry-wide practice.
Matt?
So, yep.
Yeah, I'm curious. One of the principles in the CI/CD pipeline from a security perspective is interactive testing, right? Build out test cases, test for various scenarios. How does chaos engineering either tie into some of those test and use cases, and where is it different, right? Because there are some things you can test for I believe before you get into production through some of those use case QA interactive test scenarios. So how does chaos engineering either play with that or augment some of that interactive testing?
Yeah, they're certainly complementary. The difference is testing is for things that you understand. So testing works great for simple systems. Strictly speaking, with a test, you don't generate new knowledge. You're asserting a valence on a known property of a system. It's either true or false, this property that I know exists in the system. The reason that Western science has really expanded our understanding of the universe is because it doesn't just test things. It puts out a hypothesis. This is how I think the world works. And now I'm going to try to disprove that hypothesis. And as long as I can't disprove it, my confidence grows that this is how the world works. When I do disprove that hypothesis, that actually generates new knowledge. Because now my framing of the world, my understanding of my security posture, or my availability posture, or my retry logic, or however my system is architected, my understanding is wrong, and I have to go out and discover something new in order to recalibrate my mental model. And so that really gets into the power of chaos engineering and continuous verification, and it's more a method for navigating complex systems that's more appropriate to complex systems than testing. Now, that doesn't mean you don't do testing. Absolutely, testing is a great practice, and I highly encourage it. It just won't move the needle past a certain point, whereas experimentation will.
Yeah, it's like a multi-dimensional form of testing, which I completely agree in complex systems is needed, because I can test any one given scenario, but I think what you're saying, Casey, is you have a hypothesis as to how your systems are going to react, and you're measuring multiple points within that complex system, which could generate a lot more testing. Did I capture that kind of correctly?
Yeah, and there's a fairness aspect here too. In a complex system, by definition, we're assuming that no human can mentally map all of the interactions of a complex system. And so why would we put the burden on the software engineer to write all of the tests to capture all of the possible side effects of how that system works? You just can't do that. It's not fair to put that on the software engineer. So instead, test the things you understand and experiment on the things that that are beyond that comprehension level. And so they're complementary in that manner.
Yeah, but then I'm curious on the experimentation side, right? Because there's how do you come up with the experiments to test these different hypotheses, right, against the system, because these things are constantly ever evolving, right? So these experiments in the number of experiments will continually grow and change over time.
Yeah, and that's not a bad thing. The system, I mean, and this is part of the evolution from continuous integration, which limits the rate at which we create bugs, to continuous delivery, which improves that reversibility, to continuous verification, which is making sure that we can optimize for the business properties of a complex system, and have confidence that it's doing that. Yes, those experiments will grow over time. You can come up with different conditions to search the solution space of things that could potentially go wrong. And in a lot of cases, you can automate that. So some of that is based on experience and heuristics. So for example, on the availability side, you get a lot of value just changing latency between different components. And by manipulating latency, you can discover a lot of properties about your system that you just wouldn't be able to imagine without having the data in front of you. In the security space, there's even more options, because you're experimenting on your security posture. So you might want to take a security tool, for example, and say, given I have this tool implemented, I expect that this is my security posture. Now let's see if that's actually the case. So the general guidance is for availability experiments, your hypothesis takes the form, under X conditions, customers have a good time, right? And then you want to vary the X conditions. And in security chaos engineering, and I'm speaking out of turn here because Aaron invented security chaos engineering. But in security chaos engineering, the hypothesis takes the form under X conditions, security will be notified and there should be some remediation. Right, Aaron, do you want to add to that?
One of the differences, there's a lot of likeness between chaos engineering for availability and stability use cases as from a technique perspective to security, but the focus is a little bit different. Really, the focus of the security chaos experiments are really around accidents and mistakes that engineers make as part of operating in a complex system. And it's because of the speed, scale, and complexity. Nobody's making these misconfigurations intentionally. It's happening as a result of that speed, scale, and complexity. You might have a poor understanding of what you believe the system's configuration to actually be, and there's a lack of alignment often there. So what we're doing, what you do with security chaos engineering, is you inject those conditions by which you expect to be caught. A lot of times these misconfigurations, like open ports, permissive accounts, things like that, are really the low-hanging fruit that most malicious code sort of needs for the rest of it to execute. The majority of it, not the nation state sort of stuff, but the majority of malicious code requires some kind of low-hanging fruit to exist before it can actually succeed. What we're trying to do is inject the low-hanging fruit proactively to show we can detect that when that happens before an attacker takes advantage of it.
So, Aaron, many of us in security, we view complexity as evil, right? And I would somewhat, fall in that camp. As systems get more complex, there's a higher likelihood that there could be some low-hanging fruit, like you're describing. How do we balance that complexity in security in the context of this discussion?
Yeah, I've done a lot of research on this since the experimentation with Chaos Slinger and the United Health Group. And there's two different camps when it comes to complexity in software. There's the essential complexity and there's accidental complexity. Essential complexity comes from things like Conway's Law, which states that organizations are destined to design computer systems that reflect the way they communicate as a business. Meaning, United Health Group makes money because they operate a certain way, and that finds its way into how they build software. As part of their business function. So it's hard to change the complexity in the software without changing the business. The accidental complexity comes from how we build software and the processes and how we build things and change things. And the two different camps here. I'm in the camp. There's a camp where people think you can reduce the complexity, but really I'm in the camp of really all you're doing is really moving the complexity around. And it's not about trying to reduce the complexity. It's about navigating it, understanding it, and building feedback loops of constantly understanding or building a more concrete understanding of how the system actually works versus how you think it works. Because systems engineering, and a lot of people forget this, is a very messy exercise. Our system slowly becomes stable, and verify the security becomes verified through a series of unforeseen events. And because we learn more during those outages and incidents about how the system really worked, and we're able to actually affect the security at a higher level. Because
what you just described, I often am quoted as saying, and I stole this from a network engineer I used to work with at the university, and he always said, you have to scramble a few eggs to make an omelet. And that kind of stuck with me to that, designing and implementing systems is a messy process, right?
It is. If you think about it, so day zero, right, or prior to day zero of initial launch of an application, right, you have you've got a nice, beautiful 3D diagram. You've got your pipeline's ready to go. It's been tested. You're using it. You get your tests. Everything's ready. You go live. You launch it the first week. The first couple of days are good, but after day 3 or 4, there's marketing comes down and says, we got the pricing model wrong. We need you to refactor the pricing, right? You got to refactor, right? And then the day after that, there's an outage on the payments API. You have to hard code a token. Of course, you go back and fix that, right? And then the day after that, Google hires your best engineer. It's just your system, it's how do systems become stable? Right? How do they?
Right?
You know what I mean?
Yeah.
It's through these unforeseen events.
Yeah, no, it's a very good point. So now, you're both working on different books? Did I get that right? Each of you, are you contributing to each other's books, or so you have actual copies now? Awesome.
Yeah. So this is the O'Reilly Chaos Engineering book is out now. There's contributing authors in there, and we were lucky enough early on when we started this book to get Aaron to contribute the security chaos engineering chapter in that. And O'Reilly liked what it saw, so Aaron, you've got a dedicated book to that coming out soon.
Oh, that's awesome.
Yeah, O'Reilly, they like the content. They asked, "Hey, there seems to be a lot of kind of content here, a lot of content to build on." They asked if we would write a book, and another person that's really been expanding sort of the knowledge domain in cybersecurity is Kelly Shortridge. So Kelly Shortridge is my co-author for the Security Chaos Engineering O'Reilly book. The first edition of the book, so there's going to be 2 editions of the book. There's going to be more of like the O'Reilly report, which is the 100-pager.
Yep.
And then the actual full animal book will be a year later. But the 100-pager comes out in the summer.
That's awesome. That's
great.
So you weren't happy with just a chapter. Now you have to go and write an entire book, and you're probably kicking
so
yourself, right?
painful.
Because it is a painful process.
And you can't write one book; you have to write at least 2.
Then you have to and go write more, right?
Right. But people want to hear other use cases. Like, I mean, we've got a large bank that's talking about how they do security chaos engineering. We've got a large healthcare companies talking about how they do it. A few FANG companies. Like that way, people want to hear more about the how and the who and the what, and that's what we're trying to provide in it.
The phrase of continuous verification is, I find, kind of interesting, right? When we're at Tenable, and a lot of standards, right, talk about continuous monitoring. I like continuous verification a little better because it implies that I'm actually verifying something, not just looking at what's happening. How does continuous verification play into the security chaos engineering, or even chaos engineering in general?
Go ahead. Okay, see if you're gonna.
Yeah. I just can frame up the and then you can jump in on the security piece. So it's really what we're seeing, in our interviews with the enterprise particularly over 2019, is most enterprises seem to have a good handle on CI, and they're somewhere in their journey of CD. Either an in-house tool built on Jenkins or something more sophisticated as a third-party tool, and a few of them, a dozen or so, are starting to dip their toes into continuous verification as the evolution of that process. So now chaos engineering is kind of a cornerstone of continuous verification, which is a larger category of elements of observability. And automated canaries are a form of continuous verification, and blue-green deploys and feature flags if they're used in a certain way. And so, security plays into the same theme as a business property that you want to continuously verify. Aaron, do you have a different perspective on that?
No, yeah. That's the mustard. I mean, that's what's important is like, and the key, believe it or not, the key use case is the use case where chaos engineering began, which is cloud transformation. Like it's a very difficult thing for all companies, whether it's Silicon Valley companies in the Valley or companies, large complicated enterprises and businesses. It's like. Security is always a big question. It's a big hump you got to get over in that process. Like people are always they always set unrealistic expectations. They believe they don't have the right skills. Their costs are underestimated. And so it's where chaos engineering can help in that process, or continuous verification, is that is constantly building a feedback loop. So you build something, like, did it work? You build something, did it work? Right? It's constantly, so you inject the condition by which you expect, right, and see if it actually worked. Right? If it worked or it didn't, you get additional context about what didn't work, and during the process of that learning, you're building that skill set, reinforcing confidence that yes, what we're building is working. We do have the right skills, and it creates a better culture around continuous learning, as well as confidence from management perspective of the team's abilities.
It almost sounds like I would think of that as automating the regression testing, right? And because I'm really big on regression testing, largely because I introduce bugs in our own software and it breaks other stuff. And I was like, wow, I wasn't expecting that. And it's difficult as humans to predict the impact of a change on a system. It sounds like continuous verification is a much more refined process that's building upon regression testing.
There's definitely similarities. It's just continuous verification explores a bit more and really focuses on it because it's exploring things that haven't necessarily broken in the past. But we can even in an automated way kind of explore the surface area of things that could potentially go wrong. But it also, as much as possible, focuses on end business goals. The system output, instead of how the system works internally. So really, what's great about an automated canary or something in that kind of vein is it doesn't care if say you have a microservice architecture. Your microservice architecture can be on fire, but if the customers are still happy, then your continuous verification should tell you that customers are still happy. Right? Because at the end of the day, that's what the business cares about. And, when you've got a large complex system, you're going to have pieces of it that don't work. All systems at scale have pieces that are, in some form of degraded performance. And that's true on the security side too. You're always going to have some, vulnerability somewhere. But as long as the business goals are being met, and continuous verification really hones in on that, as long as the business goals are being met by this complex system, then we don't have to care as much what's going on inside the system, which is really how we navigate complexity instead of fighting
it. It almost reminds me a little bit of breach and attack simulation, Paul, right? Yeah. In that it's kind of a subset of the verification is out validating more from an availability perspective. What are the things that my system's not ready for? Instead of doing a control validation, I mean, you're kind of looking at the complexity of the system and see what holds and what doesn't. Almost looks like a kind of a very focused, almost breach and attack simulation capability.
There is I wrote there's also some overlaps with red and purple, automated red and purple teaming, right? Like I wrote an article on opensource.com a few years ago called Red Fish, Blue Fish, Purple Fish, Chaos Fish. I didn't include the breach and attack simulation stuff, but really there are some subtle differences between how you approach security chaos engineering and the breach and attack simulations. Is that one, we're injecting fault, injecting failure, and there are certain conditions by which we do that. We don't. We're not stepping through a Node.js mass assignment attack. We're not stepping through and sending a bunch of data to the system. In a large scale distributed system, you have hundreds, thousands of microservices. It becomes very difficult to ascertain whether or not that one thing actually worked and fired or it didn't, or furthermore understand how the potential of cascading failures as a result of that. We're sort of looking at different things, but they do compound. I mean, the application. So what I'm not saying that there's no value in breach and attack simulation. I'm saying there's a combination of breach and attack simulation. So a lot of your automated purple teaming tools don't really affect software. I feel that's kind of a gap in the industry, but you combine these objective sort of testing methodologies, I think we get a better understanding of how effective our security is or isn't. And that's where we need to be. I think we need to be reducing the subjective types of assessments that we have in the business and start replacing them with more objective data.
Interesting. Yeah, you're right. The breach and attack simulation tools really kind of focus on infrastructure and endpoints and stuff, where you really focus more at the software layer and all the complexity of microservice-based architectures, for example, that the breach and attack simulation tools wouldn't even really understand how to attack anyways.
Yeah, I mean, but there is value in all techniques, though.
Right, and in combining kind of the infrastructure attack, breach and attack simulation capabilities with continuous verification at the application, and understand where some of those intersections are, because it could be a code fix or it could be an infrastructure fix, right?
Oh, precisely. And it's actually funny that after we released Chaos Slinger, we had a brief project that we just ran out of time and resources for, but we worked with Netflix to create exactly a combination of the two, combining Chaos Slinger and Breach Monkey. But we never could get that finished. But yeah, so I have explored the application of both, and there is value in, because the breach attack simulation tools can actually encourage behavior change, whereas we're really trying to more assess the engineering directly with the security chaos engineering. I guess that would be some of the difference. But
where in the maturity model for security and development do you need to be? Like, I can see some organizations that are maybe still struggling with just basic unit testing and building a CI/CD pipeline. There are things you can do when you're building that infrastructure that set you up to implement chaos engineering inside of your environment, and like, where in the maturity model should you start thinking about that?
I know. I guess I could defer to Casey on this one, but like, I would say, like, we're seeing companies, adopted various degrees of different maturities, and what people are finding out there's an open source tool that I wrote that really only works for AWS that's deprecated because I'm not at United. But like, people are just writing their own Python scripts for now. Like, and what people are finding out is they're finding out their security really doesn't work the way they thought it did in a lot of cases. And most of the use cases are around cloud or containers. But like, in terms of mature, I mean, like, really, the sooner the better. I mean, like, a lot of times all your tests will pass, and a chaos experiment won't. And it's kind of like, oh, what's going on here? Were we lying to ourselves? Is there an issue with our testing? Like, what happened? Like,
it can serve as a test for your testing process, regardless of where you are on the maturity model at some level. Yeah.
Kind of, yeah. I mean, that'd be my perspective. Casey, do you have any thoughts on that?
Yeah, I would just go back to this Chaos Monkey in particular originally came, as Aaron said, it originally came from Netflix's journey from the data center to the cloud, when essentially Netflix had 2 or 3 months of instability due to being the first customer at scale, working with auto scaling groups and other parts of AWS infrastructure. And chaos engineering was born, helping in that transition. So our advice, and we say this in the book, you want to start thinking about bringing practices like chaos engineering when you have a complex system. And the thing is, nowadays, even a simple application usually starts off as a complex system, because if you're in the cloud, you've already got so many layers of indirection between your business logic and actual silicon that you're almost everybody working in software is working with complex systems now anyway. So there's a bunch of different ways to get started, but yeah, as Aaron said, the sooner the better. Because otherwise the side effects of a complex system are going to bite you.
So tell us a little bit about Verica. How'd you guys get started, and kind of like where you at in terms of the company?
Yeah, well, we got started. I mean, when we met at Netflix, and Aaron, like I said, opened my eyes to the security aspect of it. It made sense to me that security and availability are really two sides of the same coin from a system safety perspective. And we both looked at what he was doing at United Health Group, what I was doing at Netflix, and figured there's a lot of value here. We can see that the value that our respective companies are getting from this. Let's commercialize that and bring that value to other companies. So we formed the company late 2018. We spent most of 2019 doing R&D. We built some prototypes, and we interviewed over 100 enterprise companies about their maturity, about their failures, both on availability and a security perspective. And we're pretty soon. We're still a little bit under the radar, but pretty soon we'll be announcing GA of the first module of our continuous verification tool.
That's
You're
awesome.
not much under the radar anymore. There's 25 on the live feed, and about 19,000 people will see this eventually.
But I think what's super important, and what Casey said, is you took the time to interview 100 companies, right? And not every startup does that. And putting that time into truly understanding your potential customers' problems, I think is super important, right? And you already had a lot of that experience, but you still took the time to understand the problem better, which is awesome. I applaud you for that.
And that's kind of a key thing people will see in the product is that, like, even on the availability and the security side, we're kind of we kind of own the security space on the commercially, but like even on the availability side, you see a vast difference between us and other techniques in chaos. Is we actually took the time to understand real failure at real companies, and we model our failure modes based upon real world gray failure. And we don't just make up failure modes.
Right. That's awesome.
That's awesome.
Very cool. So folks want to learn more about the upcoming product. Where can they go?
Verica.io.
Verica.io. This was not a sponsored interview, by the way. But we definitely wanted ourselves to learn more about chaos engineering and security chaos engineering and introduce the concepts to much of our audience and some of the developments.
There's also these books out there. Yep.
Yeah, and books as well. Fantastic. Well, Casey and Aaron, thank you so much for appearing on Enterprise Security Weekly.
Thanks for having us.
Thank you so much. This was a lot of fun.
Absolutely. With that, we will conclude the show. Thank you, everyone, for listening and watching. We'll see you next time on Enterprise Security Weekly.